Okay, example 19. And this one is a special case. You might have remembered on a previous question that I've said that we don't know what we get when we integrate log x. And this basically is showing you what happens. It's a kind of special case that we need to do something a little bit strange to this, basically. There is not, there is basically an integral for log x that you'll have to kind of learn and get used to. And this is basically where it comes from. And it comes from applying integration by parts to this, but saying that if we want to integrate log x and there isn't this kind of set integral where can it come from, it actually means, because if you notice at the minute, we haven't got two things there, have we, to integrate. So at the minute, we only have the one thing, the log x. We don't have, therefore, a u and a dv. So what we do is we say, rewrite this thing as the integral between 2 and 1 of log x times 1 dx. Okay? That then means that we can let u be log x and we can let dv equal 1. Okay? That's where the proof of this basically comes from, because that's effectively what we're doing now. So if we differentiate this, we're going to get 1 over x. If we integrate this, we're going to get x. And now we can do our uv minus the integral of v du. So uv is going to give us x log x minus the integral of v du. So that's going to be x times 1 over x. So simplifying that, we're going to get x log x minus the integral of 1, which means we're going to get x log x minus x. And remember, this was a definite integral, so we want this between 2 and 1. So let's plug in all the 2's, which is going to give us 2 log 2 minus 2 minus 1 log 1 minus 1. Well, 1 log 1, remember, that's saying what power of e will give 1. What power always gives 1? 0, isn't it? So that means that that's 0. So we're going to get 2 log 2 minus 2 minus minus 1, which will be minus 1. So that's your answer there. Okay, so that's just a special case. I think it does come up in the, it comes up on one of the questions, I think. Maybe there on that one, you can do that one. I haven't actually set you that one. That's just a kind of special case for you to be aware of, to be honest with you. Yeah. So if you haven't been doing the questions that I'd like you to do, so on exercise 11F, I want you to do 1, A and B, 2, A and C, 3, A and E. Question 4D. Make sure you rewrite that as x to the minus 2 there, by the way, because obviously we need these things to be next to each other, not over each other. And then have a go at question 5 and 6, please, as well. Remember that this is for the 2 lessons with me this week, so if you want to finish this off while I'm online on Thursday, you can do, okay? But just make sure it's all in, please, by Sunday next week, okay? Good luck, and remember that this stuff is tricky, so please, if you're midway through it, it comes up on my phone when you comment on things on Classrooms or Teams or anything like that. So please get in touch. Don't leave this. This is important, this topic. Okay. This stuff and the integration by substitution are both very, very important topics. So if you are struggling, please get in touch and we can talk through it. Okay. Good luck.